In this video, we'll break down what RAG is, how it works, and its practical applications. Let's dive in. What is RAG? RAG is an innovative AI approach that combines the power of retrieval-based and generative models to enhance natural language understanding and generation. That sounds complex, isn't it? So, let us break it down. In traditional LLM models such as ChatGPT, one asks their queries, and the LLM model returns results based on the training set of that model, which means the results will be generic. For example, imagine I am a solution architect for an internet service provider company, and I am tasked to build a chatbot interface for our customers where they can ask their queries. Now, if a customer asks something like, "Tell me the cheapest data plan you have," I do not want generic results from any internet service provider whose data was used to train the chatbot model. Instead, I want my chatbot to suggest specific plans from our own service provider. This is where RAG architecture shines. When rightly applied, customers would feel like having a conversation with an AI that not only understands their queries but also retrieves relevant information from our own databases to generate accurate and contextually relevant responses. Let us start with a very simplified model of a chat-based LLM model. Here is an end user asking a query. The query they ask internally gets transformed into something we call a prompt. The prompt is then passed along to the LLM model, and it evaluates the prompt and returns back with a response for the end user based on its training set. Users can then ask follow-up questions as well. And to make that work seamlessly, the new prompt needs to pass previous chat history as context as well to the LLM model. Based on this context, the model could return responses highly relevant to the context. Let us assume we have all of our company-related plans and policies already stored in some documents formatted as PDFs. Now, if we could just pass the data from these documents as a context in the prompt to the LLM, we have high chances of getting chatbot's responses to be highly relevant. A sample prompt here could be, "You are a very helpful assistant for our internet service provider company XYZ. Your task is to assist our customers with their queries. Please be nice to our customers. To answer their queries, please use the following content section delimited by 3 backticks. Please do not assume anything and answer only from the provided content section." So far so good? But there is a problem. What if there are hundreds of such documents? We cannot provide this huge context in the LLM APIs. Most of the time there will be a limit to the number of words or tokens that you can provide in the input prompt. Moreover, the data that we want to supply as context will not remain highly relevant if we pass along every single document all the time. This is where we add a retrieval step in this architecture. We need to find a way to only pass relevant chunks of information instead of all documents in the prompt. There could be multiple ways to achieve this, but one of the common methodologies is to use some form of document storage. We can post-process the PDF documents and create multiple chunks out of them. Next step is to store them in a document-based data store which would keep certain form of vector embeddings to help search with relevant text. In simpler words, we want a way to store chunks of text with some sort of hash so that most relevant chunks are easy to search for later. Now, we need to also modify our query sequence so that when there is an incoming query from end user, instead of passing it directly to LLM to get back the result, we first pass it to the LLM model to get an appropriate search keyword from the query. Next, we will use this search keyword and find the most appropriate chunks from the document data store. This way we can only get fewer, say 5 document chunks from the data store instead of the whole PDF dataset. Once we have these 5 relevant chunks which is highly relevant to our query, we can then pass it as context to the prompt that we designed previously. With this extra indirection step of retrieving the data from our own database along with our modified prompt to use only this given context to generate results from the LLM models is our solution to getting highly relevant responses for our customers. And this is nothing but the RAG pattern. Now that we understand how RAG works, let's explore some exciting use cases of this technology. RAG can revolutionize question answering systems, chatbots, and virtual assistants by providing more accurate and informative responses. It can also be applied in content generation tasks such as summarization, content recommendation, and even creative writing. And that is all for today. Thank you for watching. Don't forget to like, share, and subscribe for more content on AI technology. See you in the next video.